Let us have a discussion on the voltage transfer characteristics curve. That is nothing but the VTC curve, what we got from the CMOS inverter. Right, I have drawn a curve right in the previous video, as you can see it here, CMOS inverter, where I have drawn the curve. So this is the voltage transfer characteristics curve, where how your input is getting transferred to the output. When the input is low, the voltage is high because it's inverting, and when an input is high means the voltage is low, again it is inverting, right? So let us analyze the curve. It is very important to know the characteristics of that particular curve, right? So this is the voltage transfer characteristics curve, and when you look like this, it will become like this. And first of all, we can divide or split this curve into 5 different regions. Okay, 5 different regions. Okay, so that's the first thing we have to know. We can split this curve into 5 different regions, and we can make our analysis. Firstly, this region from 0 to a voltage called as the threshold voltage, that is VT0N. What do I mean by VT0N? That is nothing but the threshold of the NMOS transistor. Okay, so beyond the threshold, the NMOS transistor will be active. What do we mean by NMOS transistor is active? When the NMOS transistor is active, it will pull down the output, right? So the output will be immediately getting dropped to 0, because it will pull down the output when the NMOS transistor is active, right? So that is why we are having a parameter called VT0N, right? And up to VT0N, we are calling this as region A. From 0 up to a particular voltage VT0N, which is usually 1 volt, up to that it is called as the region A. Okay, and from region A to from that VT0N to a voltage called as VTH, the threshold voltage. Okay, threshold voltage beyond which you will consider everything as logic 1. This threshold voltage is different, guys. Beyond this threshold voltage, you will consider everything as logic 0. So all these voltages will be called as logic 0, and behind this threshold voltage we will be considering the voltage as logic 1. That's the magic, right? And this is VTH point, and from VT0 to VTH it will be called as region B, and VTH alone, this one voltage alone, will be called as C, region C, right? That is the VTH alone. And from VTH to a voltage which is called as VDD, that is the supply voltage, plus threshold of PMOS transistor. Threshold of PMOS transistor will be in negative, guys, because you know that the PMOS will be active when we apply logic 0 to its gate, right? When you apply negative voltage to its gate, we discussed about this already, right? When you apply negative voltage to the PMOS, it will attract the positive carriers and it will form a P channel. That is why it is called as PMOS, right? And for that the voltage will be negative. So that's why we are adding the VDD and the voltage, and from VTH to this particular voltage level, we are making it as region D, right? And beyond this voltage, we can call this as region E. So there are 5 regions in this curve. Why we are making these 5 regions? It is basically that we are making an analysis more simpler, and for an input we have to understand in which region that the CMOS inverter is existing, so that we can find out the critical voltages in that particular region. So what do we mean by critical voltage again? So we'll make one more video, and that will be the next, right? Thanks a lot.